Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Fruit Loops, which was actually, I think it still is a child's cereal. Well, actually, I guess you can eat it as an adult too. But basically, you have essentially loops that are different colors, and they're supposed to be different flavors of fruit. But I don't think they were actually really had fruit. Well, they didn't have fruit in them. It was basically just fruit flavoring. But this is by Michael Lefkowitz, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We also have difference loops, where adjacent digits along a large loop differs by exactly the digit on the same colored mini loop. So for example, if this were say a 1, the cells in on this big green loop must have a difference of 1 between them. So you could have something like 4, 5, 4, 3, 2. You can't do, well, no, you can't do that. 4, 3, 4, 4, 3, 6, 7, 8, 9, 8. That doesn't work. But something along the lines of this. Okay. Well, maybe 4, 5. Oh, this is not. Anyways, you would have to have a difference of 1 between these digits on this loop, if that were the case. Huh. Maybe that tells us something there. Anyways, that's an example of how these difference loops work. They essentially work, well, yeah, they have the difference of exactly that digit, which is in the smaller version of that circle, the loop. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so how does this work? These have the same difference. So this obviously has the different distance than that. So this is a certain flavor. That's a certain flavor. And I think these have to be the same. So those are the same. Which means this must be yellow. So then these cannot be the same. That's the problem, right? So these cannot be the same here, right? So you could have blue. I guess you could have red here. And then this is blue. But the problem is to get back to this is going to be weird, right? So how do these loops actually work? Well, we know this cannot be the same as that. So these are the same. And then these are the same. That means I think these have to be the same. And these have to be different. Right? Yeah, so this has to be the same going to this. So I think it's the same for the way that this interacts with this circle. So this has to be the same these have to be the same. They go to the same digit here, which goes to the same digit here, which goes to the same digit here. That means what? This is too many colors. Right. You cannot do the other way. So you can't go, they have to loop around, right? So they have to essentially go back to the same digit. So if we tried having this and this be different digits, the problem is if these two are the different digits, then these two have to be the same to be able to go down or from one to the other. It has to be the exact same. But the problem is then that would force both of these to be the same digit for going here to there and there to there. So that doesn't work. So that's why it has to be this way. So we know that these two are the same digits. Okay, so we have same digit here. These two are the same digit. And these two have to be the same digit. We know this is the same digit as that. We don't know if these can be different than these. So this is green here. So this has to be some sort of, you can have a difference of 1 and 2, but I don't think you can have a difference of 3. So say you had 3, 6, 9. Yeah, you can't have different digits there. You could have 2, so you could have 1, 5. No, 1, 3, 5, 7, 9. That works. So that means green has to be 1 or 2, and pink has to be 1 or 2. Right? Because they must match this pattern, and therefore they have to have be able to have 5 digits going in a certain direction. Okay. So these are the same. These are the same. This is different. These are the same. So we'll mark those as blue. Interesting. These can be sort of any combination. Because it can be up to 8, essentially. So this is 1 or 2. If this is 1, this would have to be a 2 here. So therefore, this would, if this is 1, this is 3. And then 5. Then 7, then 9. If this is 2, this would be 1. So then this would be 2, 3, 4, 5, and 6. So we know either way these are 3. So this is 3. If pink is 2, that would force 1 to be there. So this could not start from 1. This would have to be 9. This would be 9, then 7. Okay, so then if pink is 2, that would mean 3, 4, and 5. This would be 1, so this would have to be 9, 7, 5 here, which is a contradiction. So pink cannot be 2. Pink has to be 1. And then green has to be 2. So then this is 5 and 5. This is 7 and 7. And this is 9. So we can remove the coloring here. This then has to be a difference of 1. We don't know which way it goes. We know this cannot be 3, 5, or 7. It's got to be the middle digit here. So that means it's got to be 5 through 9, 4 through 8, 3 through 7, 2 through 6, or 1 through 5? Well, this can't be 3. So if this is 5, this is 7. Can't be that. If it's 4 and 8, this is 6, which could be the case. If this is 3 and 7, this is 5, which can't be the case. If it's 2 through 6, this would be 4, which could be the case. And if it's 1 through 5, this is 3. So this has to be either 2 through 6, and in this case, it would be 2 here, 3 here, 3 here, 4 and 6 here. That would be 4 here, 4 here, 5 here, 5 here, or 6. Or it could be 4 through 8. So 4 and 8 could be here. That leaves this as 5 or 7. And this is 5 or 7. And then this would be 6 here. Okay, 2 cannot be here. So this is 2, 4, or 8. This orange, well, we don't really know. So this is 2, 3, 4, 5, and 6. Or 4, 5, 6, 7, 8. Or 4, 5, 6, 7, 8. Okay, 7 is here, 7 is here, which means 7 has to be one of these two. So if this were 7, that would mean this has to be 7 going here, then this is 8. That's possible. So you have 8, 7. Otherwise, this is 7. This is all in the same box. So it has to be, it can be 4 difference or less. If it's 5 difference, you can't have two cells that are 5 difference apart from the same digit and have 2 different digits there. So this is a difference of 4 at most. So this is 1 through 4. Same with this. This has to be a difference of 1 through 4. It's 1, 3, or 4 here. This could be multiple ones. We don't know. So this is a difference of 1 through 4. If this is 7, this is 8, and then this would be 1. Right? No, that's not true. Seven's here, 3's here. Where is 3 in row 6 then? Can't be here because of 3 in the boxes. Can't be here because of the way that the ring works. So this must be 3 here. Okay. Where is 1 in row 6? It cannot be here, so it must be one of these digits here. Which means 1 has to be one of these 3 digits there. I think this is guaranteed to have a 5, right? It's either 2, 3, 4, 5, or 6, or 4, 5, 6, 7, 8, or 4, 5, 6, 7, 8. So one of these is 5, and one of these is 5. Okay, that's good to know. This has a difference of 1, 3, or 4. We're not sure which. 7's here, 7's here. 5 can't be here or here. Where else could things be? 1 is here. This is 3. 3 can't be here. This digit... Okay, remaining digits in box 5 are... This could be 1, and then we have 2 in one of these 3. 2. So this could be 2, 3, 4 going that way. It could be 4, 5, 6, or 6, 7, 8. So there's nothing that's required there. 2 is there. 4. This could be 4, 6, 8, or 9. No 9 here because of 9 in the column. What can the differences here be? They could be 1. They could be 2. They cannot be 3 because of 3 in the column. They could be 4 if this is 4 and 8. Does that work, though? If this is 4 and 8, it could be 2 and 6, but okay, if it's 4 and 8 here, that forces this to be 6 and this to be 2, but that's not going to be one apart from each other. So that does not work. So 4 doesn't work, and 2 and 6 has the same problem. 2 and 6 forces this to be 4, which makes this 8 here, and 4 and 8 are not going to have a digit that's one apart from both of them. So it cannot be 4 and 8. Could be 4 and 9, which is 5 apart. It could be 2 and 8, which would force this to be 4, 5, 6, which is possible. This is what? 8, 7, 6, 6, 5, 4, or 4, 5, 6. So either way, there's a 6 here, which means 6 cannot be in the rest of the row. Interesting. Hmm. 1, 2, 5. You could have 6 here. You could have 7. You cannot have 8 because 1 can't be in any of these cells here. 1 has to be one of these two. Hmm. Um. So if this is 7, this cannot be 8. So it would have to be 7, 4, and 1. So let's try that. If this is 7, this can't be 8 because it can't be 8 going to 7 here. This can only have a difference of 3 at most. So it cannot be 7, 2. So this would be 7, 4, 1. So this would have to be 3 of a difference. 4 then would have to go to 5 here. So we have 5 here, 6 here, 6 here, 7 here, 7 here, and that's 8. So this can't be 1 or 8. So how would this work then? So far that's looking okay. So, okay. One thing we do know then. If this is 7, this has to be 8 here because this has to have a difference of 1. If this is 7, it has to be 4 here. So this can never be 2 here, which means this can never be 2, 3, 4, 5, 6. So this has to be 4 and 8. This is 5 or 7, 5 or 7, and both of these are 6. So that's 6, that's 6. This is 5, 7 as a pair, which eliminates 5, 7 in the rest of the column and the rest of the row here. This is 6, which eliminates 6 in the rest of the box. So again, this could be a difference of 1. It could be a difference of 2. Remaining digits of column 3 are 1, 2, 3, 4, 6, 8, 9. So no 1, 3 here, no 3 here. Hmm. So if this is 7 and 8, this cannot... Oh, how does that work? 7 and 8 does not work there. Because if this is 7, that's 8. How do you can only have one apart here, because you can only go up 1 to 9 from 8. But that would include a 7 here. So this cannot be 7 and 8. Therefore, this must be 7, which makes this 4, this 5, that's 7, this is 8 here, which eliminates... This is 3 apart, so this is 3, that's 7, 4, and 1. This can't be 1 or 8, it's 4, which eliminates 4 in the rest of the box. This then has to be 1 here. 3 eliminates 3 in the rest of the column. This has to be a difference of 1, 6, or 7. Interesting. If it's 1, you cannot... So if it's 1, a difference of 1, this is 8, 9 as a pair. 9 can only go to 8 here, but we already have an 8 in the box, so this cannot be a difference of 1. It's a difference of 6 or 7. And if it's a difference of 6, you would have to have 2, 8 here, which would have to be next to 2, 8 here, but we can't have an 8 there. Therefore, this must be a difference of 7, which makes this a 2, 9 pair. This can't be 2 or 9, it's 8. 2 or 9 is going to be 7 away from 2 or 9. So then this is 2, 9 as a pair, which eliminates 2, 9 in the rest of the column. That leaves 1, 4, 6, 8 as the remaining digits in the column. You cannot have a difference of 9 between two digits, so this must be a 2 here, which makes this 9, which makes that 2. So this has to have a difference of 2. It cannot have 1 there, so it's 4, 6, or 8, so this must be even. Cannot be 2, 4, or 6. That forces this to be 8, which is 2 away from 6, which is 2 away from 4 or 8. No 6 here, no 6 here. Okay, so this is 8, that's 6. Remaining digits of box 4 have to be 1, 5, 4, and 6. And this cannot be 1, 5, so it's a 4, 6 pair, which eliminates 4 and 6 in the rest of the box, so this can't be 4, 6. 6 eliminates 6 here, so that's 4, which makes that 6. Remaining digits of column 2. We have 1, 2, 3, 5, and 9. This can't be 5 here, or 3 because of 3 or 5 in the box. What are the differences here? Again, they have to be 1, 3, or 4. If it's 1... If it's 3 here, this would have to be specifically 2, 5 with 8. But we can't have 8 there because of 8 in the box. Also, this is 1, 3 as a pair remaining in column 4. So this cannot be 3. If it's 4, this is 1, 5, 9 as a triplet. So this would have to be 9, 5 here, and then 1, if this is a difference of 4. So that is possible. If it's a difference of 1, though, that means you have 1, 2, 3 here. So you could be 1, 2... So it'd be 1, 2, 3. 1, 2, 3. Or it could be 2, 3, 4. If this is 2 and that's 3 and this is 4. So this can't be 3. So it cannot be 1, 2, 3 there. So it's either 5, 9, and that's 1. Because it can't be 1, 5, because that would eliminate all possibilities for that cell. If it's a difference of 1, we have a 1, 4, 8 triplet, actually, in box 1, which eliminates 1, 4, 8 in the rest of the box. Oh, this can't be 5 or 9. Well, where are 5 or 9 going to be? They have to be on this orange ring, which is basically going to be 4 apart from each other. So then this is 4. This becomes a 5, 9 pair because it can't be a 1, 5 pair, because that would eliminate all possibilities for this cell. 5, 9 eliminate 5 and 9 here, so this is 1, which just makes that 5. This can't be 1 or 9, it's 2. This can't be 1 or 2, it's 3, which makes this 1, which makes that 3. 5 and 9 go to 1 there. 4 eliminates 4 here. 1 eliminates 1 here. This is 4, 8 as a pair, which leaves this as 2. 1 has a difference of 4 with 5, which makes that 9. This is 4, 8 as a pair, which eliminates 8 here, so that's 1. Remaining digits in column 1 are 4, 8, and 9, and this can't be 4 here, so this must be 4 there. And the rest we can probably just do with Sudoku. Well, we have to do with Sudoku because we have all these numbers already set. So 1 can be, well, let's do row 4 and 5 and 6 because we have 7 digits each. This is 4 and 6, no 4 here because of 4 in the column, so that's 4 and 6. We have 7 and 8 here. That's still 7 and 8. Remaining digits in row 6 are 5 and 9, and this can't be 5 because of 5 in the column, so this is 9, that's 5. Row 3, we have 4, 6, and 8, and this can't be 4 or 6. That makes this 8, which makes that 6, and that makes that 4, and that 8. Okay. Remaining digits. Let's do column 5. We have 2, 3, 6, and 8, and these cannot be 3 or 8, so we have to have a 3, 8 pair here. So this can't be 3 because of 3 in the row, so this is 8, that's 3, which makes this a 2, 6 pair. 6 can't be here because of 6 in the row, so that's 2 and 6. Remaining digits in this box 8. It's 2, 6, 9. Okay. So no 2 here, no 6 here. Remaining digits in column 6 then are 4 and 5. No 5 here, so this is 4, which makes this 5. Remaining digits in row 1. We have 1, 2, and 4. No 2 or 4 here, so this is 1. This can't be 1 or 4, it's 2, which makes that 4. Remaining digits in row 2 are 3, 7, 9. No 3 or 9 here, so that's 7. 8 eliminates 8 here, so it's 7 and 8. This can't be... this is 3, 9 as a pair then here. Remaining digits in column 9, we have 3, 5, 9, and 5 cannot be here, so this 5 must be here. This is 3 or 9. Remaining digits in column 7, we have 2, 6, and 8. This can't be 2 or 8 here, so that makes this 6, which makes this not 6, that's 9, which makes that 2, which makes that 6. So this can't be 2 anymore, so this has to be 8, which makes that 2. 8 eliminates 8 here, so it's 9 and 8, which leaves that as a 9, which makes that 3, that's 7, and that a 1. 9 eliminates 9 here, so it's 3 and 9. And that's the solution. Pretty interesting, actually, how these interacted. Particularly, this part, I think, was very interesting. This became rather trivial because of the way that these interacted, right? So, well, actually, no, that's not true. We had to have this one to figure that out, right? Right. So it was really this pink interaction with the green Fruit Loop interaction. That was very interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.